Define the term resistivity. Now, I don't have the exact words for this, you should get them in your notes, but resistivity, you could say, if you wanted to be smart, resistivity is the inverse of conductivity. Now, you're better off to get a few words out of your notes and give them back to your lecturer the way you received them in your course. Anyway, the formula looks something like this. Resistance equals resistivity, that's rho, symbol for resistivity, times L, the length over the cross-sectional area. So here we're asked to calculate the resistivity. So we have to manipulate this formula because we want to get rho on its own. We want to make rho the subject. So we can throw the A across and up by multiplying both sides by A, and we get R times A equals rho times L. And finally we want to get rho on its own, so we can throw the L across and down by dividing both sides by L. So we get R times A over L equals rho. Now I like to put my stuff here on the left and put this guy over here. That doesn't matter, I'll just swap them from each side. They're still equal. Rho equals R times A over L. Now we're given the resistance, aren't we? Yeah, there it is there, 1.7 by 10 to the minus 2 ohms. We're given the length. Be careful now, the length has to be in meters, so 500 centimeters is the same as 0.5 meters. So that's our length, L. And then we have to get our cross-sectional area in meters squared. It's given to us in 5 millimeters squared. Now there's 1,000,000 millimeters squared. There's 1,000,000 of them little guys in each 1 meter squared. So to get your figure, to transform it from millimeter squared to meter squared, we have to divide by 1,000,000. Right? So it's going to be 5 divided by 1,000,000. Right? And an easy way to do that is to get your 5, the decimal point was here, but we're going to knock it 6 places to the left. 1, 2, 3, 4, 5, 6. And that gives us 0.00005. And that there is meter squared. Now, you do this on the calculator and you mess around with it, and you'll eventually come up with 5 by 10 to the minus 6 meters squared. 5 millionths of a meter. And that is our cross-sectional area A. So rho is going to be R 1.7 by 10 to the minus 2 multiplied by our cross-sectional area, which is 5 by 10 to the minus 6. So use your fraction key on the calculator and put all this stuff into it. So on top, you're going to have 1.7 by 10 to the minus 2 multiplied by 5 by 10 to the minus 6. Right, be careful with that. And downstairs you put 0.5 plus equals, and we get a resistivity figure. Rho equals 1.7 by 10 to the minus 7, and the units then are going to be what? Well, you see, it's going to be ohm meters, right? You might remember that, or you might not. But you see, you have ohms here for R times meters over meters. Well, it's meters squared for area over meters to the power of 1 here. So you'll end up cancelling, this m will cancel with one of them m, so you end up with ohm meters. So that's our resistivity.